A highlight of the 3 days that we were there was taking a tour of where Frontier is.
A definition of scalability was it's where capability grows faster than complexity.
It's put supercomputing at something of a crossroads where the next thing isn't just to get to zettascale.
Compensation, mission, and culture. If they're getting paid well, then that's great. That is exactly what we should do.
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hey Shaheen, great to be with you again.
Great to be here. What's our topic today?
Well, a big part of the HPC industry was the HPC User Forum at Oak Ridge National Lab. It's an organization run by Hyperion Research. They put the emphasis on users. So most of the conference is not Hyperion speaking and it's not vendors speaking. They both speak, but not very much. It's really on the users, very much public sector, the national labs to a great degree. It was my first user forum and I was really impressed. It was a great conference.
Yes, I've been to a couple and I've liked them as well, and they do a great job. Like you said, a lot of emphasis on users.
Yeah, and to get into this conference, to get permission to go, and then to get into it, to get onto the Oak Ridge campus, took some doing, especially on the security, and there were forms to fill out and
makes sense,
and so forth and so on. But I was impressed that once you got in, you weren't being tagged and followed by security guards. I mean, it was quite open and very relaxed atmosphere. A highlight of the 3 days that we were there was taking a tour of where Frontier is.
Nice.
The new #1 exascale supercomputer. And that was the big theme of the show, was that we've gotten to exascale. How did we do it? And to a degree, where do we go from here? They took groups of attendees down to the computer room outside of it. Mm-hmm. You sort of look through a glass, but there was Frontier. I was lucky enough as a media member. I got a private tour with Justin Witt, who is Associate Director of OLCF, the Oak Ridge Leadership Computing Facility. But there again, I'm in the belly of the beast with Stephanie Ellers, my publisher. And it was very relaxed. I mean, here's the $600 billion system that is a very big deal in terms of global competitiveness. And we were opening doors, looking at cabinets and so forth and so on. So I don't know. I really felt good about that. I'm thinking in other countries, it might not have been quite that way culturally, but it was great.
So you got to see and touch the beast.
I did. I got to see and
awesome.
touch it. And it was really impressive. For one thing, the system is much less noisy. There's certainly noise, but not the noise of, say, Titan and to a lesser degree, Summit. Now, the data storage end of the system, that's quite noisy, but the compute end is quite quiet. And the reason is that it's all liquid cooled. They showed us the blade.
Yes.
And everything in it, there's just water flowing through that blade everywhere.
It's got pipes flowing through the boards. Yeah.
And, along those lines, I'm sure you know this, but the plumbing system, getting all the water they need into that computer room, these gigantic pipes, just out of scale. And then the electrical power that's needed, same thing, just very formidable, really impressive.
So the beast eats electricity and drinks water.
It does. And, water's not the problem, but electricity is. There's a lot of talk at this conference about power consumption and supercomputing. I think the estimated annual electric bill for Frontier is $18 million. And
nice.
Oak Ridge taps into the Tennessee Valley Authority power hydro source. But even there was talk that 80% of the power for that facility still comes from coal. The other point being that to get to zettascale, right now, a fellow from RECON got up and said, zettascale is a non-starter because power consumption costs are off the hook and not manageable.
Well, if you imagine that you're using current technology to do it, it's going to be 1,000 times bigger in every dimension.
Yeah.
So 1,000 times more expensive. Maybe you get some discount.
Volume discount, yeah.
But, what is 600 million times 1,000?
Yeah, exactly.
600 billion, is it? Yeah, okay. That's a chunk of change.
Or 18 million times, whatever.
18 million times. I would say that's 18 billion a year to run it.
Mm-hmm.
And how big a system was it, like physically? How many buses worth of cabinetry? It was about 100 cabinets or so.
That's right.
So now that means 100,000 cabinets. So
yeah.
very clearly, current technology isn't going to do it. Yeah.
Current technology and current power sources won't do it. So, but Very interesting. Now there was a presentation about El Capitan, and you've been following that a little bit too in terms of some of the new developments.
Yeah, well, we already knew that it was going to be AMD chips, and they talked about it being an MI300, so-called APU, which is a combination CPU, GPU packaged together. Now, if you put two things on the same die, but what is a die these days anymore? Is it on two tiles, but on the same chip? Okay, right. Does that mean that the communication is faster? Probably. Anyway, they call it APU, and they talked about that, so that's nice to see. They talked about Slingshot 11 being the interconnect from HPE Cray. But the part of it that was really interesting to me was the software stack, that they're using the so-called TOSS software stack on this rather than the vendor software stack that typically they would use. So that's worthy of a look that we should do in a future episode.
Yeah, yeah. Lots of talk about the software end of supercomputing. The Exascale Computing Project, which was $1.5 billion plus funded program over 6 or 7 years. That was a huge part of it, was building out the software ecosystem. That project was led by Doug Cothy, who's now taking Jeff Nichols' spot. Nichols is retiring, and Doug is going to become the associate lab director. I had to sit down with him, and a big part of his orientation will be on the software end of Oak Ridge and its supercomputing infrastructure as they move forward.
Yeah, as you look at the future, where we've come and where we want to go, and look at scalability beyond exascale, it reminds me that a definition of scalability that I always liked was it's where capability grows faster than complexity. And that means performance grows faster than price. It means the benefit grows faster than cost. And systems don't grow linearly. So as you scale them, some parts will be fine, and some parts that were not a problem become a problem. And small problems that you could ignore at small scale cannot be ignored at higher scale. So all of that has to play a role as you look at going beyond exascale, and also decide how you're going to go do it. Will it be the same model? I mean, I remember our conversation with Jack Dungara a few episodes ago when he was saying, are future systems going to be based on merchant technology? Or are they going to look the same as a Large Hadron Collider would, or a Big Fusion Lab might, or a aircraft carrier, or some specialized jet fighter? That is something to really remember. Now, there are new modes of computation. We talked about memory-based non-von Neumann architecture briefly with Thomas Sterling, but there's also quantum computing that we've brought up with everyone that we have talked to in this podcast. So was there anything about quantum computing in this conference that would point to the future?
I think you're hitting on an important sort of sub-theme that was discussed quite broadly at this conference, which is exascale seems to be kind of it's put supercomputing at something of a crossroads where the next thing isn't just to get to zettascale and scale out and deliver more throughput. It's this whole ecosystem around these systems that increasingly will be the focus. Now, as far as quantum goes, there is early stage, certainly the theme that we all know now that quantum is not going to replace supercomputing. It will augment and complement according to the specialized roles that quantum is good at. Again, there was talk of early stage thinking about bringing in quantum and hooking it up with some of these leadership computing systems.
Yeah, I think that's a really great idea. And it's very much in line with what they're doing in Europe with the Jülich Supercomputer Center, where they installed a D-Wave system a few months ago, and they're actively pursuing hybrid classical quantum HPC-oriented setups that I believe will be the norm. Now, we're still early days in quantum.
Very early. Yeah.
It still needs to figure out what technology, what modality is good for what sort of application, and how to actually use it for effect. For example, one thing is clear is that quantum computing is not for big data. Okay, what does that mean? If it's not good for big data, what sort of small data apps can I use that are also highly compute intensive?
Yeah, what would that be, Shaheen?
Right. So the immediate answer, besides cybersecurity, which I consider the unquantum market, because you're trying to avoid it as much as you're trying to leverage it. You can leverage it for provably random numbers. You can leverage it for quantum teleportation or quantum key distribution. But at the end, you're doing it because quantum decryption is a problem you're trying to guard against. But there's also quantum chemistry, quantum physics simulations where you have a natural alignment with. And those are kind of small data, highly compute intensive applications. Like the atomic number of oxygen is, well, it's 8. Okay, that's one number.
Mm-hmm.
And
Yeah.
maybe you can define a small or large molecule with not a lot of data and then let it crunch.
Right. Bob Sorensen got up and spoke along with Travis Humble.
Oh, great. So you had Bob, and he's, of course, a good expert in all of this. Yeah. And so is Travis. Yeah.
Yeah, they were impressive. But as Bob said, this is a marathon. We've probably run 200 or 300 yards so far. But and he also said that, as we've heard before, the biggest market for quantum technology is the quantum industry. It's in early development stage.
Yeah, well, the ecosystem is building, and then there's a lot of development. You can now actually go and buy control systems and buy this kind of photonic doodad and that kind of laser thing that was more difficult to do a few years ago.
Mm-hmm.
So all of that has been developing the way it should. So there's a lot of progress, even though not a lot of milestones are achieved. They're doing better with circuits. They're doing better with different modalities, with trapped ion, trapped atom, neutral atoms, silicon spin, photonics, and figuring out what each one of them is really good at. So those are all really good progress.
Another major topic of the conference, and this sort of surprised me, although maybe it shouldn't have, it's non-tech, but it's staffing.
Yes.
The labs and supercomputing centers generally, it's a chronic problem of hiring people out of graduate school, training them up in HPC AI and data science, and then they leave.
Mostly. I wonder why.
Yeah. And I was speaking with Terry Quinn of Livermore, and she said, big tech, they've got so much more money than
there
we do.
You go.
And they offer much more money.
They can outbid, and they can run things with completely different norms. But, bigger picture, I am so glad to see that HPC people are getting their value. If they're getting paid well, then that's great. That is exactly what we should do, because in the bigger context of humanity, they represent the highest level of scientific engineering expertise that the planet has ever seen. So for them to be nicely compensated is a very nice thing to see. I like that.
Well, Oak Ridge has hundreds of job openings. I think Doug Cothey's, what will be his organization, I think I might have heard the number 200 openings, and very hard to fill them. So some of the discussion moved toward, okay, what does DOE do to counter this? Bob Sorensen brought up, he emphasized the word mission. If you take a government job, you're taking on a national mission. So it appeals to patriotism, global competitiveness with other players like China. I know Mike Bernhard, who was head of community at Exascale Computing Project, he said, when you go there, it's about doing something bigger than any one of us working on this project. He said for himself, it's been far more rewarding than anything I spent on a vendor's payroll. And if you do go to the private sector, you're in that quarterly earnings cycle. You've got to make sure that the revenues have come in for the quarter to keep the stock price up, all those sorts of things, whereas that's really not an issue at a place like Oak Ridge. But the other sentiment that was widely expressed is this has been a long-term problem, but it's really getting worse. It's becoming more and more of a challenge. So, and Shaheen, we talked about the Google AI engineer last week who declared that Lambda, the chatbot, is a person with a soul, and he's put on administrative leave. I was really surprised. I guess I'm old school, how openly critical this guy was on his blog of Google, his employer, charging them with unethical behavior. But as you and I were saying, why? Because he knows he can go out and immediately get another job. Might get a raise in pay.
He's in demand. Yes. Well, yeah. I think a lot of things are going on here. Mission really is the right word. As you were talking, the 3 words that I was scribbling down is compensation, mission, and culture. The whole idea of recruitment marketing and employment marketing is a thing now. We work with a lot of startups, and traditionally they talk to investors and to customers. Now, increasingly, they have to talk to their prospective employees and to existing employees. They have to really worry about the compensation, total compensation, salary, benefits, bonuses, stock options, incentives, but also to the culture. What is the work environment like? What are the management practices are like? And there is really where we can observe a bit of a renegotiation of just how much power employees want to claim. So they're pushing on these boundaries, and they're going to say, no, I feel it needs to be like this. And if you have been an engineer at one of these big hyperscaler sort of environments, you may already have enough means to just do what you want to do. And you may not even need additional employment. So it's a very different environment. And I think that government labs and traditional academic labs, they need to recognize this. And they have in the past. The same thing happened with electrical engineers and engineering professors to some degree some years ago, when they just couldn't compete with industry and they had to dial things up.
Yeah, I mean, the worm is turned in, generally speaking, toward workers. The demand for labor throughout the economy is so strong, but here's a strong example of that.
Yeah, this is a double whammy. I mean, not only is it sort of a secular unemployment being low and hiring people being difficult, it's also that when you do find the right person, you have to compete with people who are at a completely different level in their game. And so now the importance of culture and mission become even more important.
Exactly. So there we go. It was a very interesting week, a very well-run conference.
Yes. Hyperion guys do a great job. And also nice that you got to see and touch the real exascale machine. That is really cool.
Yep. And someday I'll share snapshots of me standing in front of it.
Well, you did share one photo on your Twitter account that we're going to have to highlight so folks can go check it out.
You're right. Stephanie took pictures of me there and she tweeted them out. That's right.
Well, good stuff. Glad you went there. Good story. Awesome.
Okay. Thanks, Shaheen. We'll talk again soon.
All right. Take care.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.